To connect the 2-bit incrementing counter on the trainer board, after we reach the solution given by the expressions here, it turns out we need 2 flip-flops. We'll call them flip-flop 0 and flip-flop 1. So we need 2 JK flip-flops. We label them as flip-flop 0 and flip-flop 1 to help us with the connection. Now we know that J0 is actually J of flip-flop 0. K0 is K of flip-flop 0. J1 and K1 of course belong to flip-flop 1 inputs. So before we start with any connection, we'll choose 2 of the LEDs as our outputs. We'll call them output 0 and output 1. These are going to be the 2 bits for our counter, output 0 being the least significant bit. The first step is to connect all the clocks together of these flip-flops to one of the clocks on the trainer board. So this clock we connected to the top pin here, and we'll repeat the same for the flip-flop number 1, flip-flop 1. Next, we notice that J0 and K0 are both equal to 1, so we'll connect J0 to K0 with the shortest wire that we have, and then we'll connect one of the pins here to 1. 1 is the positive 5 volts on the trainer board, or it's the VDD. That will give us a constant 1 on the trainer board. Next, we'll connect J1 to K1 because they're both equal to, so J1 to K1 because they're both equal to Q0. Q0 is the output of flip-flop 0. So first connect J1 to K1 and then take a wire from Q0 connected to either J1 or K1 because they're connected anyway. Now the connection is complete, except we need to connect the output pins. So Q0 is output 0. We'll take a wire from Q0 connected to output 0. Next, we'll take a wire from Q1 connected as Q1 as output 1. To test the connection, we'll first make sure that the clock has a comfortable speed. You can move the knob to the left slightly or to the right until we see that the LEDs are changing their values or their states at a very comfortable speed. We should notice that output 0, output 1 will both be 0, and then output 0 will be 1, output 1 will remain 0. This is going to be the decimal 1. So this is the expected result. It will be 0, 0, and then 0, 1, 1, 0, and then finally 1, 1. Remember, output 0 is the bit on the right, it's the least significant bit. Output 1 is the most significant bit.